We're going with 9-2. This is more of solving a times x squared equals b. There's a takeaway is that when b over a is not 0, the equation ax squared equals b has two solutions. X equals the square root of b over a, or x equals a negative square root of b over a. And that comes about because of the nature of squaring. Let's take a look at the warm-up I've got here and just run through it real quick. If a squared equals 36, then what does a equal? In other words, what value or values of a would result in 36? Well, 6 times 6 equals 36, and a negative 6 times a negative 6 also equals 36. So a equals plus or minus 6. We've got a little bit of a different problem here with b squared plus 1 equals 36. So what might we do here? Let's take a look at it. We could have two possible values for b squared, right? It's a plus or a minus, but I've got this plus 1. So, algebra, I can just get it out of the way by subtracting 1 from both sides of the equation. So b squared equals 36 minus 1 is 35. So from the above and what I learned here, that tells me that b equals plus or minus the square root of 35. If I was going to use an approximation, I'd have to indicate it was an approximation. Otherwise, I'm going to use an exact value. Can that be simplified? Well, 35 is 5 times 7. Those are both prime numbers, so the answer is no. There's no simplification. What about number 3? 3 times c squared equals 36. I have a coefficient that I need to get rid of. Again, algebra helps me do that. I am going to divide both sides of the equation by 3. So 3 goes into 3 one time, I get c squared. 3 goes into 36 12 times, because 3 times 12 is 36. And so I get then that my c is equal to plus or minus the square root of 12. Well, 12 can be factored because 12 is 3 times 4 and 4 is 2 squared, which means that I can pull a 2 out of the equation, right? So 2 times the square root of 3, and this is plus or minus 2 times the square root of 3. Okay, there's still some more here. I don't know that we need to go through all of them. But when we're looking at exact values, unless we have a perfect square, we're going to end up with something like 2 and 3. Okay, let's get on to applying this knowledge. First up, we want to solve 4x squared equals 100. Well, we just learned from our previous work what we need to do is to go ahead and solve this equation, see what kind of results we could get. So that would be one method of doing it, of solving it, which could be pretty useful. So let's just take a look at that. So I got 4x squared equals 100. 1/4 times 4x squared equals 100 times 1/4. 4 over 4 is 1. X squared equals 4 goes into 125. I'm going to get that x is equal to plus or minus 5. So I take the square root of both sides and I take the positive and negative square root. So that's algebraically, we've got an answer. Well, there may be problems that aren't as simple, and we might need a little bit more help, and we could graph these problems and see what kind of result we get. I'm going to do a quick graph here, and sometimes it's enough square it up. Sorry about that. Okay, there's a nice graph. It's going to be x, this will be y. And I now want to make a graph for the equation of 4x squared equals y. Not 100, y. I'm just looking for kind of results from the calculation that I can use to help me with this. Since it's a 4x squared, it means when x is 0, y is 0. It's on at the origin. And I can now go from here, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. I'm out to 6. And I need a few points to help me in estimating this graph. It's going to go up pretty quick, so I'm going to go by tens. 20, 30. Way up here, getting right in my way. We'll drop this down to here. Make our t-table, x, y, x is 0, y is 0, x is 2, 2 squared is 4, 4 times 4 is 16, so I got a 2, 10, 20. I'm up in between these. We know, well, we calculated 5 is 100. We already know that one. 1, 2. And we know it'll be symmetric. So if 2 gave me 16, negative 2 will give me 16. I'll come across, make this point. If 5 gave me 100, a negative 5 will give me 100. And I've got my curves. Now, it's a little rough in something like this. If you can graph it on some graph paper or do it with your graphing calculator, what you'll find is you can draw the horizontal line through y equals 100 and see where it intercepts your graph. And those would be then your approximate solutions. Another method to solve this is to build a table using Excel or tables in your graphing calculator and go down the table till you get to the result. We've built a table here by calculating by hand, but you could do a more elaborate table and get the results for your calculation. So that's 3 methods of solving 4x squared equals 100. Now let's take a more classical quadratic problem. A stone is dropped from the 555-foot Washington Monument located in the National Mall in Washington, D.C. Determine how long the stone will be in the air using Galileo's equation of d equals 16 times t squared. In the equation, t is time in seconds that it takes a heavier than air object to fall d feet. Round your answer to the nearest tenth of a second. So we know that it's 550 feet is the height. That's how far it's going to go. And this is going to be equal to 16 times t squared. 16 is the force of gravity, or half the force of gravity in our customary system. Did this before. We're going to divide both sides by 16. So I got 550 feet divided by 16 equals t squared. We can do a little bit of simplification to this. 550, let's see, 16 go into that evenly? I don't think so. Nope. Well, we'll just live with this because we're going to be looking for an answer rounded to the nearest tenth, so we're going to get a decimal approximation anyway. So our next step, we've done our division, is to take the square root of both sides, and I want the positive and negative square root of 550 over 16, and I want the positive and negative square root of t squared. I'm going to just ignore this. I just want to know what's the root of t squared, which is just t, and t equals plus or minus the square root of 550 over 16. So let's see, 550 divided by 16, okay, square root. Ooh, I got to be careful and put parentheses. So square root, open parentheses, 550 divided by 16, close parentheses. And that gives me, to the nearest tenth of a second, 5.9 seconds. And I said plus or minus. Well, would there be a negative 5.9? What would happen if I had negative time? Yeah, it would go backwards, right? And nothing happened before that. So the beginning of time was 0. And so there won't be a negative. And in fact, I can get rid of that and say that t is equal to 5.9 seconds, simply the positive result for our calculation. Okay, next example. This asks us to solve 6 times 4n minus 3 squared equals 54. A little bit more complicated problem. So 4n minus 3 squared equals 54. Well, my first step is to, I think, get rid of this coefficient. I'm going to divide both sides of the equation by 6. So 6 over 6 leaves me with 4n minus 3, still in parentheses, still squared, and that equals to 54 divided by 6 is 9. Okay. Well, from here, rather than expanding this and making this into a larger quadratic, what I know is that 4n minus 3 squared equals 9. So I know that the square root of 4n minus 3 squared is equal to plus or minus the square root of 9. Well, the square root of a square is just the number, so I now know that 4n minus 3 equals plus or minus the square root of 9 is 3 equals plus or minus 3. I have two equations I need to solve here. I need to find out if 4n minus 3 equals 3 and 4n minus 3 equals a negative 3. Those are my two problems I need to solve to find out what n is. Well, here in this case, I add 3 to both sides. So 4n equals 6. So n equals to 6 over 4 is 3 halves. And this case I add 3 to both sides. Negative 3 plus 3 is 0. 4n equals 0, so n equals 0. My solutions for n, for the equation we solved, n equals 3 halves and 0. Those are our two solutions for the equation. That's it for 9-2. I think it's pretty quick. You've got a number of different tools you can use to solve your problems. You can solve them algebraically, you can solve them graphically, you can solve them using a table. Good luck on your quadratic solutions.